Right, grade nines. Moving on to example 2. The first question is asking us to prove that triangle BCD is similar to triangle ACE. Okay. So we've got to prove that the smaller one is similar to the bigger one. So how we start off a question like this is I'm going to write down what they've asked us to prove. So I'm going to say in triangle, and it is BCD, and triangle ACE. All right. What I'm going to do here is I'm going to prove it using this equiangular condition. All right. So I need to prove that 3 pairs of angles are equal. Then I can say that the 2 triangles are similar. Why? Because of angle, angle, angle. All right. So as you saw there, we need to prove 3 angles. So I'm going to write 1, 2, 3 for our 3 angles. So first of all, I can see here, now you have to keep this in order, grade 9s. BCD is the smaller one. So whatever angles I list for the smaller one is going to go under BCD. For whatever angles I mentioned for ACE, I'm going to list it under this one over here. All right, so we can see straight away that angle D is equal to angle E. They're both 90. Now D lies in the smaller triangle over here. So I can say D is equal to E in the bigger one, this ACE triangle. And my reason for that is both equal 90 degrees. That's what they told us. Okay. Now, again, I'm going to show you what the triangles look like. We have this B, C, D, A, C, E. And what you can see there is they share a common angle of C. All right. So we can say that C is equal to C. It has to be, it's the same thing. And they share that common angle. And our reason for that would be common. All right. Now, how are we going to prove this third angle? Well, it would have to be angle B and A, but we don't know anything about them. That's where this thing comes in right from the beginning that I showed you. It says here, if 2 pairs of corresponding angles of 2 triangles are equal, now that's what we proved there. 2 pairs of corresponding angles are equal, then the third pair will also be equal. In other words, B must be equal to A from what I showed you with this example over here. So what we can say now is angle B is in the smaller one. So B must be equal to A. All right. And what we can say there is third angle of triangle. Third angle of triangle from our angles in a triangle. Okay. So what we can do now is, now this is where it becomes important, grade 9s. So therefore, I'm going to read it down from here how I proved it. Just reading it down like this. So how you listed in the beginning is not important, but once you've proved it like this, that is important. So I'm going to say, therefore, triangle DCB. DCB similar to triangle ECA. Triangle ECA. That way you will never get the order wrong. Okay, so let me repeat that. How you list it over here is not important, but how you prove it is important, and you read it down like this. So DCB, DCB, ECA, ECA. Okay, and you won't get the order wrong. And our reason for this is angle, angle, angle. And we've proved the first one. Now, question 2 is asking us calculate B and C. Okay. So what I'm going to do now, because B and C are the sides of the triangle, I'm going to get my little proportions coming out, or my little fractions. And that is condition 2 over here. And I showed you how to do that with this example over here. The very first example, how I did the little hop thing. And that is why your order is important, and that is why it's important to read it down like this. So let's do our little hop thing. So DC over EC. So we know that DC over EC will be equal to, do our next little hop thing, CB over CA. So CB over CA will be equal to, let's do our third hop, DB EA. DB over EA. All right. And my reason for this is equiangular triangles. And remember, grade 9s, it's all shorthand. Equiangular triangles. Okay, so what I'm going to do now is I'm just going to fill in my information for all of these sides. Okay, so what is DC? DC is 16 over, what is EC? Now, EC is both B and 16, but the entire length will be these two plus. So we can say here that this is B plus 16. That will be the total length of EC. Equals CB. CB is this one over here, which is 20 over CA. Now CA is that total length, so it's 20 plus 10, which gives us 30. Equals DB. DB is that length over there. Sorry, this is 12. I missed that. So DB is 12 over EA is C. Now, just like this example over here, grade 9s, I'm going to find the fraction that has both the numerator and the denominator, a number at the top and the bottom. And it is this one over here. Okay, so that's our main one, because we know for definite what that is. And what I'm going to do is, you can see with your other two fractions, we have the unknown there and an unknown there. So I'm going to set this one equal to that, work it out, set that one equal to that, and work it out. Okay, so we'll get two different equations. So the first one is 16 over B plus 16 will be equal to 20 over 30. All right. To get this on its own, I'm going to multiply up by the B plus 16, because that's what we want to find out. So 16 is equal to 20 over 30 multiplied by, and it's going to be a bracket because it's the whole thing. Okay. To get this on its own, I need to divide both sides by this 20 over 30. So it's 16 divided by 20 over 30 equals B plus 16. Tip and times, so we get 16 times 30 over 20 equals B plus 16. I'm just going to work that out on the calculator. So we get 16 times 30 over 20, and we get 24. So 24 equals B plus 16. To get the B on its own, take the 16 to the other side, and it becomes a negative. So it's 24 minus 16, and we get B is equal to 8. All right, so that's for our first one. I'm going to do the same for this one over here. So we have 20 over 30 equals 12 over C. I want to get the C on its own, so just multiply up to get it out of the bottom there. So it's 20 over 30 times C equals 12. To get rid of this, we have to divide by that. So we get C is equal to 12 divided by 20 over 30. I'm going to tip and times them. And then we can just plug that on the calculator. So we've got 12 times 30 over 20, and we get C is equal to 18. And we've solved for both the B and the C. All right, so grade 9s, I need you to practice on these. You are guaranteed to be examined on the question like this, okay? I know initially when you look at it, it's quite tricky and difficult, but it's not that bad once you get used to it, okay? So grade 9s, what I would like you to do is exercise 12.5 for me, please. Thank you.